Hello my dear students, this is Akash HD and welcome to the HD Physics classes. Hope so you all are doing really great. So student, in today's video we are going to learn all about the electric current basics. Okay, as of now you know very well electric current is one of the fundamental quantities, SI unit ampere and dimensional formula capital A. But we are going to learn a bunch of all the basics and all that. Okay students, so let's start the video. So under the electric current, first let's see what is actually the electric current. Okay, so see here. Electric current is defined as the rate of flow of charge through any cross-sectional area of the conductor. Very, very important point, cross-sectional area. The area from which the electrons are going to pass that area. Okay, that's why the name is the cross-sectional area. Okay, it can be defined in two ways. Okay, so first one, what is given here? The average current. Okay, so see what is this? It is the value of electric current in any time interval. Okay, like time interval means, let's take for example t equal to 2 seconds to t equal to 5 seconds, na? Some like that time interval. Okay, so see, if delta q charge flows through any cross-sectional area of conductor in delta t time interval, then it is given by. So see here, normally what will happen that here students, here in this chapter you know very well number of kinds of material is possible, like conductor, insulator, semiconductor. Okay, but here we are discussing exclusively for the conductors, and in conductors what are the charge carriers? They are the free electrons, and electrons are which charge? Negative charge. Okay, remember that here this chapter is basically for the electrons. If I am not telling anything, that means conductor is there, charge carriers are electrons. So what will happen that here, for example, if you will connect this conductor to the battery, okay, then what will happen that here electrons will start to flow. Okay, so this is going to the cross-sectional area, no? So what will happen that here, this is a negative terminal, this is the positive terminal, electrons will travel in this direction. Okay, like this is the basic, and this is going to the cross-sectional area. Okay, so what we have told, in delta t time interval how much charge is going to pass? Delta q. So students, this is given by this average current. We can write here this I average is given by this delta q by delta t, or we can tell total charge by total time taken. Okay, even here we can write here this Ne by T also from the quantization of the charge. So anything you can use, I equal to delta q by T or Ne by T. Is it, students? I hope so. Very clear. Okay. Now after that, one more concept is there, orbital current concept. So see here, what is this? See, if charge revolves in a circle with a time period capital T, then this orbital current. So see here, here I have taken here one circle. Okay, and what is happening that here? Here I have taken here some electron is there. Now this electron is there. Now, and what is happening? This electron is revolving. So what I will take here? I will take here one very small hypothetical cross-sectional area. Okay, so what will happen that here? First electron will cross this cross-sectional area at t equal to 0. Now, and let's take for example it is going in this direction. Then again after one time period it will cross the same cross-sectional area here. Okay, so based upon that only we can tell yes here t equal to 0 first, again after returning t equal to capital T, then t equal to 2t, 3t and all that. So what will happen that here in this situation, students, this orbital current is given by charge by time period, q equal to 1 by t. Is it? This formula at least you please remember that here. After that some other formulas maybe you have to replace sometime, like f equal to 1 by t. Now this may be useful, or maybe it may useful omega equal to 2 pi f also, depending upon the situation. Okay, or we can use here what this will come here, 2 pi by capital T. Is it? And one more formula may be useful depending upon the situations here. I can write here this v equal to r omega in a circular motion. Okay, so any of this formula can be used to get the answer here. Is it? Great. Now after that, students, we are going to see here the instantaneous current. Let's see what is the instantaneous current now. So see here, it is the value of electric current at any instant of time, not time interval, at any instant, Okay, so see here, if dq charge flows through any cross-sectional area of conductor in dt time, then it is given by. Okay students, so it is given by, say, this instantaneous current is given by I equal to dq by dt here. Okay, and what will happen that here? as you know very well, what is the significance of the differentiation? Slope. Okay, so what we can write here, even this is the slope of a QT curve. Which curve? The slope of Q2 curve will give us current. Okay, after that, if I write in another way also, if I do the cross multiplication, then what can I write here? I can write here, see, this dq is equal to I dt. Now, if I will integrate here, this also I will integrate here. Then students, what will happen that here? I can write here q equal to integration of I dt. And what is the significance of the integration? Area. What is this, students? Area. Area under IT curve. Okay, so you know very well, differentiation means slope, and what is there? Integration means area. Is it? Great. Now, let's move to the next one here. Some important points are there. Is it? So, let's go through it. Anyhow, you know very well, electric current is a scalar quantity. Even in 11th also we have learned like electric current is having magnitude, it is having direction. But why it is scalar? Because it does not follow triangle law of a vector addition. That's why this is which quantity? Scalar quantity. Next one, see. Its SI unit is the ampere, as I have told you, one of the 7 fundamental quantities. Na? And its CGS unit is the ab ampere here. Na? Very rarely it will be used, but okay, remember that here. And remember that here, this 1 ampere is 1 by 10 ab ampere. Okay, kindly remember this also. Sometimes they use here, there. Okay. Now see, its dimensional formula is very easy, capital A only, and see, very well see. As a matter of convention, the direction of electric current is opposite to that of a electronic current. Okay, because students, as I have told you very well, now what I have told you, let's take for example, if this is the conductor here, as I have told you very well, and this is connected to the battery. It is connected to the battery. So what will happen that here? Let's take this is positive, this is negative. Actually, what is happening that here? The electrons are going this side, now because here excess of electrons are going this side. So actually this is used to be the direction of the electronic current. Okay, but normally what you learn even in 10th also, you learn very well the electric current always flows from where? Positive terminal of the battery to the negative terminal of the battery, like this. Okay, so here this is which current? This is the conventional direction of the current is there. Okay, that's why the conventional current direction is always opposite to the electric current. Okay, this is the one thing. Even sometimes you know very well, let's take for example, if one proton is there, no? If one proton is going in this direction, E plus, so even in this direction only we will take here the current. Okay, but similarly, if I talk about here one electron, if this electron is flowing in this direction, then you know what will be there? The conventional current direction is in which direction? Opposite direction of the electron's motion. Is it? So I hope so you have understood very well. Okay, great. Now let's see here, one question is there. Let's go through the question. So see, how many electrons pass through a bulb in 1 minute if the current is 400 milliampere? Okay, so first let's note down the data here. Time how much given here? 1 minute. 1 minute. So 1 minute how much is there, students? 60 seconds. Okay. After that, if we talk about here the current how much they have given here? Na? Some constant current is there, 400 milliampere. That means 400 into 10 to the power minus 3, or we can write here anyhow 4 into 10 to the power minus 1 ampere. Okay, and what they are asking here, how many electrons? That means they are asking the value of n, how much. Okay, so students, you know very well what formula I have told you, I equal to delta Q by delta T, or we can write here NE by T. So from here we can write here N equal to this IT by E. Okay, just put here the value. IT how much is there? You can see very well, 4 into 10 to the power minus 1 into time how much given is here? You can see here 6 into, even I can write 10 to the power 1. So minus 1 plus 1 will cancel out here, and 1.6 into 10 to the power minus 19. Okay, so what will happen, students? Here see this one and this one over, so we can write here see 24, 6 into 4, 24. And you know very well, na, 1 by 1.6 into 10 power minus 19 means, even I remember, 6.25 into 10 to the power 18. Okay, you can simplify it and you will get here how many electrons will pass, because this data you used to remember, because we know very well in 1 coulomb negative charge 6.25 into 10 to the power 18 excess of electrons. minus 1 coulomb. Plus 1 coulomb means deficiency of electrons. In 1 coulomb, how much is this one? 6.25 into 10 power 18. That's why I have just written here directly. Okay, great. Now students, let's move to the next one here. See, if an electron revolves in a circle of radius pi by 2 centimeter with uniform speed of this one, find the electric current. Okay, so again, let's note down the data here. The data is what here? R equal to pi by 2 centimeter, that means 10 to the power minus 2 meter. Always in terms of SI, most of the time. Otherwise, slowly you will learn when to convert, when not to convert. Okay, and speed, how much is given here? Speed, students, that is given here 6 into 10 power 5 meter per second. Okay, so here students, you know the formula here. What is the formula? See, as I have told you, I equal to Q by T, but here electron is there, na? So we can write as E by capital T. Okay, but in the question they have given R and V, but they are asking capital T. Okay, so first we'll write here. You know very well what is this? V equal to R omega. Okay, so we can write here V and here R omega, how much here? 2 pi by capital T. Okay, so from here students, if I will write here the T will be what here? Anyhow 2 pi R by V, na? Kindly check out very well, na? 2 pi R by V. So here students, if I write here the formula, orbital current formula, just put the value T, how much here? 2 pi R by V. So kindly put here, it will become here EV by 2 pi R. Because I always do with the basics, na? So students, just simplify this. Electronic charge 1.6 into 10 to the power minus 19. Speed, how much given here? 6 into 10 to the power, how much here? 5, 5. And after that 2 pi into R value, how much is given here? Let's see, pi by 2. Okay, so pi by 2 into 10 to the power, how much is given here? Centimeter, na? Minus 2. Is it? Kindly check out very well. We are correct, na? EV by 2 pi R, because T value is how much here? 2 pi R by V. We put the value here of the T, 2 pi R by V. Okay, and we'll simplify this and all. When pi square is coming, na, pi square you can take approximately 10. So when you will simplify this here, this answer will come here in a ampere. You have to just simplify. And remember that here students, this pi square you can take directly 10 also. No problem, approximately. Okay, great. Now students, see, charge flow through a cross-sectional area of a conductor is given by T cube plus 2T minus 1. Calculate average current from T equal to 1 to T equal to 2 seconds. Okay, so first let's go to the average current. So students, this average current is given by formula. What is this? Delta Q by delta T. But remember that here when we are solving the numerical, final time 2 seconds, initial time 1 second. So directly we can write here Q2 minus Q1 by 2 minus 1. Okay, so Q2 will be what? Here you have to put T equal to 2. So what this will become here? It will become here 2 cube means 8. Then 2 into 2, 4. So 8 plus 4, how much? 12. 12 minus 1, 11. Is it? Minus. Q1 how much? Put here 1. So 1 plus 2 minus 1. So 1 plus 2, 3. 3 minus 1, 2. And by 1. Is it? I hope so. Calculation easy only. So what this will become here? It will become here the 9 ampere. Is it? Maximum to maximum, it will be correct only. Okay. Second students here. If they ask what? Instantaneous current. So small I is given by dq by dt. Is it? So we should know the differentiation here. D by dt of q, how much is given here? See, t cube plus 2t minus 1. Okay. I write here directly. D by dt of t cube, how much is there? 3t square. Plus 2. Differentiation of t, how much is there? 1. Minus differentiation of constant 0. So students, it will come here, see, this 3t square, and how much will come here? Plus 2. Okay. After that, at which time they ask here? They ask at the t equal to 2 seconds. Okay, 2 seconds. So put here t equal to 2. That means 2 square means 4. 4 into 3, 12. 12 plus 2, how much here? 14 ampere. Okay. So you can see very well how in a very easy way we have calculated the average current and the instantaneous current is there. Okay, great. Now let's move to the next one. Now we are solving here the different kinds of questions, nothing else, so that we should habituate it for all that. Now see, current flow through a cross-sectional area of a conductor is this one given here. Calculate charge flow from t equal to 1 to 3 seconds. Okay, so remember that here one basic I am telling you. See here, when this charge is there and you have to calculate the current, do the differentiation. But when current is there, you have to calculate charge. You have to do what? Integration. This is the basic. Okay. So as I have told you very well, this q is given by integration of the I dt. Okay, put here the value of I. What is coming here, students? See, 4t cube plus 2t minus 1 here. Okay, and here dt. Where to where? 1 to 3 second. That means here this is a definite integration. So t equal to 1 to 3 second is there. Okay, so we have to do the integration. So see here please, if I write here the integration, 4 integration of t cube means t to the power 4 by 4. Formula, integration of t to the power n dt means 2 to the power n plus 1 by n plus 1 plus 2 integration of t dt means t square by 2 minus integration of the dt means t. So here where to where? 1 to 3. Okay, so now we can write here this charge q is given by, right here this 4 and 4 cancel, so t to the power 4. Okay, again this 2 and 2 is cancel, that means plus t square, and here how much is there? Minus t. Okay, where to where? 0 to 3. Okay, so 0 to 3, not 0 to 3, 1 to 3, 1 to 3, 1 to 3. Okay, so see this is 1 to 3. Okay, so just put here the values here. First upper limit, so it will become here what? 3 to the power 4 plus 3 square minus 3 minus, then put t equal to 1. So 1 plus 1, 2 minus 1, 1. Okay, and when you will simplify this here, 3 to the power 4, how much here? 3 3 is 9, 9 3 is 27, 27 plus into 3, 81. So 81 plus here how much is there? 9. Now 3 square na 9 minus 3, and here minus 1. Okay, so what this will become here? 81 plus 9, 90. 90 minus 3, 90 minus 3, 87. 87 minus 1, 86 ampere. 86 ampere. Okay, and in second part what they are asking, average current from t equal to 1 to 3 seconds here. Okay, so anyhow this is the first part, and second part very easy. If they ask the average current here, very easy, just as I have told you, what total charge by total time. So charge how much is given here? 86 coulomb, see, coulomb, 86 coulomb, na unit of the charge is coulomb, 86 coulomb, and time how much here? 1 to 3 seconds. That means how much time interval? 3 minus 1 means 2. So what this will come here? 86 by 2. That means 2 4 is 8, 2 3 is 6. How much coming here? 43 ampere. Okay. So students, here we have done with the very basic how to do charge and the average current. Okay. Great. Now students, here we are going to see somewhat graphical concepts and all that. So see, first one, calculate current ratio from following QT graph here. Okay, so see here please, very important. What used to be there? They used to give this side T, this side Q, and they used to give some graph. Okay, like this one here. This is one graph, this is one graph. This is for material A, this is for material B. Okay, and some angles used to be there. Let's take this angle 30 degree, this angle 60 degree. Okay, so you know very well what is the significance of the differentiation slope. So in this situation, this slope is given by I equal to dq by dt, and here we can write here even tan theta. Okay, this is the formula is there. So students, based upon that, if I write here now current IA by IB, ratio of the current. So tan theta na, so it will come here. For A means how much angle? 30 degree, and for B how much angle? 60 degree. Tan 30 how much here? 1 by root 3. Tan 60 how much here? Root 3. That means what this will come here? It will come here 1 by 3. Is it? So the ratio of the current will be how much is there? It will be 1 by 3. Okay. After that, students, if we go for the second one, what is given? Calculate charge flow from what to tell? Following active graph. From the following active graph. So see here please. Again, let's take right here like this here. Now, this is T, this is I. Okay, and let's take some this kind of graph is given here. Now very famous, now that's why I am taking like this. So what is there? Let's take given like this is there. Let's take 0, 1, 2, 3, and let's take here it is given here the 10. Here unit, anyhow ampere, here second. Okay, otherwise have to be very careful which kind of unit is also given here. Okay, so what will happen that here, students? Even you know very well, Q means integration of the I dt. That means what is this? The area under the curve. So area under the curve means this area. Okay, this area. So here you can get it even with the like triangle, and then maybe rectangle, then again triangle. But remember that here this is called even the trapezium. In case of trapezium, what will happen that here the formula used to be how much is there? Half A plus B into H. But then you will ask what is this, all this A, B and H. So remember that here A is this side here, A, this is the B, okay, and this one. Distance between two parallel sides is what here? H. So students, when you will write here, what this will become here? Half. Value of A how much here? See, 0 to 3, so 3 directly, plus B how much here? So see, 1 to 2, that means this length how much is there? 1, okay, into height how much is given here? 10. So what this will become here? 3 plus 1, 4 by 2, that means 2. So 2 into 10, how much coming here? 20 coulomb here. Is it very clear? No? 20 coulomb. So kindly see here very well. So student, in this video, we have just learned the basics of the electric current and all that. Okay students, so keep studying, keep doing.